Review for test 2 for business finance. So this, I'm going to try to pull up each question on the review, put it on my whiteboard here, and then solve one question at a time. So hopefully it'll go fairly smoothly. So this is our first question, and it says we've got this company where they give us 7 years of their earnings per share. They have so many shares of stock outstanding that they're selling for $45 a share. And they expect their dividends will be 50% of the 2019 earnings per share, which they give us here. You can't see that real great, but it's $4.45. And then the dividend is expected to grow at the same rate that the earnings per share are growing. Their current debt is at 8%, and they're taxed at the 40% tax bracket. So A says compute our after-tax cost of debt. So all we're going to do is take that 8%, that's the before tax cost, and multiply that by 60%, or I'll put that in decimals, 0.6. And how I came up with this 0.6 is because they're at the 40% tax bracket. So then the net of tax would be 100% minus that tax rate, or 60%. So if we take 0.08 times 0.6, that gives us 0.048. or 4.8%. So that's going to be our after-tax cost of debt. So that's our first one. Okay, then we will add another little box and we'll move on to the second one. Oops, let me delete that because I don't like the color. So we'll just go like that. Okay. So then our second thing says, okay, now compute the dividend growth rate. So to do the dividend growth rate, we're going to use our time value money keys on the calculator, and we are going to have the difference in the years. So 2019 minus 2012, let me make this bigger, gives us 7. And that's our N. We're trying to compute the IY, that's what we're looking for, so we'll skip over that for now. And then, so if we're following our calculator, then the present value is going to be the 2012 dividend. So the 2012 dividend, or sorry, earnings per share, that is 2.5. Whoops, why does it keep going away? And then we'll hit the plus or minus button. Plus or minus button, and that's going to be our PV. Then there's no payment, so we're going to zero out the payment. And then the 2019 earnings per share is going to be our future value. And that is the $4.45. And again, that would be positive. Then we will compute the IY. So if I put that into my calculator, again, 7 is my N. The 2.5, make it negative by hitting the plus or minus button, is my PV. Zero out my payment. 445 is my future value. Compute the IY. I get 8.586, or if we want to round it to the nearest tenth, 8.6% is going to be my growth rate. So that's B. Then C says, okay, now compute the cost of common equity. So there's one more thing that I have to do before we do that, and that is to compute my the expected dividend. So in this case, it tells us up there, it says that the expected dividend is 50% of the 2019 earnings per share. So that's going to be the 445 times 50%. And that gives us $2.23. I guess if I round it, again, that might be a little bit I'm going to round it to the nearest cent though. Okay, so then that's the next step we have to do. We have to do that before we can compute the cost of equity because it's included in that formula. So then now if I come down here and say, okay, now my cost of equity is going to be calculated by taking my expected dividend, which is the $2.23, and then dividing that by the I'm struggling to find it. But divide that by the selling price or the proceeds. So up there, kind of behind my little arrow, $45 a share. So that's $45. And then we're going to add to that our growth rate, which is the 8.6%. So if you want to do it, like kind of how I'll do it is I'll take the 2.23 divided by 45, and that gives us 0.0495 6, and then plus, and then convert that growth rate back into a decimal, the 0.086. So then we have 0.1355. So if we want to round that to the nearest, we go up to the nearest sixth. So then 13.6%, because it's 0.13556. So then that would be our cost of common equity. All right, I'm going to move that over here. Okay, then our final thing we are going to compute is our weighted average cost of capital. So our weighted average cost of capital is going to be our percent financed with debt, which it tells us in D that their capital structure is 60% debt and 40% equity. So that's going to be the 60% that's financed with debt times our 4.8% after tax cost of debt, plus then the 40% that's financed with common stock equity times what we just calculated, the 13.6% of common stock equity. So then how I do that, and again, you can do it a couple different ways, but just to take the decimal work out of it, I'll go 60, push the percent button on my calculator times 4.8, push the percent button on my calculator, and then push equals, and that gives me 0.0288. So it does all the decimal work for me. Just, sometimes students will screw that up and leave some decimals and then some whole numbers, and then you get a wacky answer. So again, do the same thing, 40, push the percent button times 13.6, push the percent button and then push equals, and that gives us 0.0544. And then we add those together for our total weighted average cost of capital, 0.0288 plus 0.0544, and then we get 0.0832 or 8.3%. If we round it to the nearest tenth. And then always do a double check again because it's a weighted average. So it should be above the 4.8 but below the 13.6, and it is. So that seems reasonable. So we are good with that. So that is our first question. So then I will clear that canvas and we'll start with our second question. So then if I go back to my sheet here, my second question is to compute the cost of preferred. See if I can just copy and paste that over here. Doesn't like my pasting, darn it. What if I open that note to me? Let's see if it lets me paste it there. Okay, yes. All right, so we'll do it that way. We'll do it note. So we have compute the cost of preferred stock if the stock pays a dividend of $8 and currently sells for $68 per share. Can I make it a little bigger? Or did I just not copy the per share? No, per share. Okay, well, good enough, right? Okay, so then if we come over here and we say, all right, well, if we're doing our preferred stock, and again, sometimes your preferred stock can be right in the weighted average cost of capital computation. A lot of the problems in the textbook don't have that. They have them separate. So our cost of preferred stock is going to be calculated by taking that dividend that it pays, the $8, divide it by the selling price per share or the proceeds per share. Again, if there were fees, we would subtract those out, but in this case, there's not. So that gives me 0.1176 or 11.8% if I want to round it to the nearest tenth. Okay, so again, hopefully that one's fairly easy. All right, then we move on to our third one. Now let's see how I can do this one. So let me copy that. And then we'll see again if I can do it that way. It does, but I wish it would make me, I wish it would let it go bigger. Doesn't really let me size it. So that's right here, maybe this. No. All right, let's see what else I can do. All right. So let me see what else. Maybe if I just copy that part of it, let's try that. So then that is our years. Sorry that I struggle a little bit going between the two. And what it asks us to do, though, is compute the net present value of those two projects using our cost of capital. That's 10%. Okay. So then, and then again, I'll put it on here just so we remember. Compute the net present value. So when we do this, I'm going to use our cash flow function. And then for project S, I'm going to put in my cash flow for year 0 is going to be 800. You got to push the plus or minus button to make it negative, and then push enter. Your cash flow for year 1 is going to be 600. Hit enter. And then that frequency is a 1. It'll default to a 1. Then our cash flow for year 2 is 300. Hit enter. And then now in this case, we can make our frequency a 2 because we get 300 2 years in a row. And those are my only values, right? Right. All right, so come back. Okay, so then we'll put those into our calculator. Then we come over to the net present value. We make our I equal to 10. And then we're going to hit compute on the net present value. So again, go into our calculators, 800, hit the plus or minus button to make it negative, hit enter, arrow down. Always know you got to arrow in between these functions or in between these fields. Then we get to the cash flow for year 1, hit 600, push enter. The frequency defaults to 1, so that's fine. Then 300 is our cash flow for year 2. That frequency is 2, hit enter. And then make sure you don't have anything in future years. You can zero out everything in your cash flow function by hitting the cash flow function button, the second menu, and the clear work if you want to make sure everything's all 0 before you start. Then come over to your net present value, put in 10 as your I, hit enter, arrow down, and compute. And then that gives me $218.78. Okay. Then we'll go ahead and do the same thing for the project 2. So again, our CF function, and then we go into project L. Cash flow for year 0 is going to be 800, again, plus or minus. Plus or minus button. And then hit enter, sorry. Don't forget to hit enter because then it won't stay in that field if you do not. So then we have 200, enter, a frequency of 1. We have 400, enter, a frequency of 1. And then we have 600, hit enter. And then again, our net present value, the I is still equal to our cost of capital, which is 10, and we'll compute the net present value. Okay, so again, go back to our cash flow function. Our cash flow for year 0 is still the 800 negative. Cash flow for year 1 is 200, hit enter, frequency of 1. Cash flow for year 2, 400, enter, frequency of 1. If you're going over top of what you just did, make sure it's a 1 and push enter. Cash flow for year 3 is 600, push enter, and the frequency is 1. Come over to the net present value, I equals 10, arrow down and compute, and we get 163.19. And if we had to choose between these two ones, say if it asked, if this is a mutually exclusive projects, you're going to pick the one with the highest net present value. So that would be the project S. Okay, so that is that. Okay, then we have more to do with this though. So then it goes on to say, now calculate our discounted payback period of project S and calculate the payback period of project L. So let me scoochie these up and then we will do more. So we've got the, the discounted payback period. Project S. Okay, so then to do the discounted payback of project S, we have to kind of tab it out to say, okay, we've got our year, we've got our amount, and then we have a cumulative total. So the year 1, so the year 1 for project S, we've got 600 in there, and then our cumulative is also going to be 600 because that's all we've earned. Year 2, we add 300 to it. So we can see at that point we're going to go over. So if I go back up here, I say, okay, I still need 200, right? Because I want to make 800 to pay myself back completely. And I'm going to get there in year 3. So then if I take the 200 and I divide by the 300 that's coming in, that will give me the point in time that it will pay back. So again, it'll be 2.667 years is my, oh darn it, I'm doing the regular payback period. I apologize. All right, so this is just the regular payback period of Project S. Now I'll add to that though. Now I'll do the actual discounted one. My apologies, I was not reading carefully. Okay, so now the discounted payback period says, okay, well, it isn't just as easy as doing what I did because these values are different. So we have to compute the present value of the cash flows discounted at the weighted average cost of capital. Okay, so then if we do year one, we're going to have 1 as our N, 10 as the IY. We're computing the present value, so we'll come back to that, zero out the payment, and then the $600 is the future value. And then we'll compute our present value. So if I put those into my calculator again, the end of year one, discounted at 10%, which is my cost of capital, no payment. I'm going to receive $600 at the end of year one, so that's my future value. Discount that back to a present value by computing that present value. We get 545.45. Okay, then we'll do the same thing for year two. Now our N goes out to 2. We're at the end of year two. The IY is 10, 0 the payment. Now our future value though is 300, and we will compute the present value of that. So 2 becomes our N, our IY is still the same. There's still no payment, $300 future value. Come back and compute the present value, and that gives me 247.93. Now let's just do a quick little addition of those two. So we're not quite up to our $800, so we have to go one more time. So then that takes us out to year 3. 10 is the IY. Still 0 payment. And now the future value again is still 300 because we get 300 for 2 years in a row. And we'll compute the present value. So really all we have to do with this one is change our N to 3 and then compute the present value. So we get 225.39. So then if I'm kind of doing my little cumulative total, so if I say my year, my amount, and then my cumulative, first amount was the 545.45. Then year 2, I added to that the 247.93, and I was real close at that point. So the 545.45 plus 247.93, I'm up to 793.38. So then I still need $6.62 to get to my payback. So then obviously in year 3, I'm going to get there. So then in year 3, I've got 225.39 coming in, but all I need is the 662. So if I divide that by the 225.39, I get 0.03. So it's 2.03 years is my discounted payback. So then again, when we compare it up to, whoops, this one I'm saying this one wrong. Let me go back to this one real quick. This one it's 1.67 years. So it takes 1 full year and then part of that second year. Then, because normally they include me, and normally your discounted payback period is longer. Once you discount those cash flows, you'll realize it takes a little bit longer to pay back. But the 2.03 years is still good. So I think that's good. Again, I was supposed to do the regular payback for Project L. instead of project S, but it's set up the same way as project S. So I feel like, you know, you have the ability to do those. So that should be good. Okay, so then if I come back over to my next one, now we're computing the internal rate of return of these following projects. So I'll come over here, clear my canvas, and start over. So then again, let's go back and copy these and hope that all that copies over like it did for the last one. Okay, so perfect. All right, let's see if we can make it bigger. All right, so again, we're calculating the internal rate of return. All right. So when we do that, again, we're going to go to our cash flow function again. The cash flow for year 0 is going to be the 7,800. Hit the plus or minus button to make it negative and push enter. Our cash flow for year 1 is 3,000. Push enter. And that frequency is going to be a 1. My cash flow for year 2 is 5,000. Push enter. That frequency is also a 1. Cash flow for year 3 is 5,200. Hit enter. That frequency is also a 1. And then my cash flow for year 4 is 3,200. Hit enter. And then that frequency also defaults to 1. Then now we'll come over to the internal rate of return and push compute. So again, go to our cash flow function, 7,800, hit the plus or minus button, hit enter, arrow down, 3,000, hit enter, arrow down, frequency of 1, arrow past that again, cash flow for year 2, 5,000, push enter, arrow down, frequency of 1, arrow down again, 5,200, hit enter, arrow down, frequency of 1, arrow down one more time, 3,200, and our cash flow for year 4, arrow down, defaults to a frequency of 1, so we're good. Come over to the internal rate of return button, push that, and then push compute. And we get 36.88, or if I want to round to the nearest tenth, 36.9% is going to be my internal rate of return of that project. Okay, then we have calculate our modified internal rate of return. So I'll clear this one out, and then we will come over here and I will copy this. Okay, so I can scoochy it? That's fine, I won't scoochy it. Okay. So then we'll come in now to calculate the modified internal rate of return. What that does is it says, okay, when we calculate our regular internal rate of return, the assumption is that the project is earning that cost of capital throughout the life, so that any cash flows coming in can be reinvested at that higher rate. The modified internal rate of return says, okay, well, that's not probably true. We're gonna invest those future cash flows earning at least the cost of capital. So to be more conservative, we should go through our time value of money keys. It's a 4-year project, so that's our N. And use our cost of capital as the IY to say that's how we're going to be investing in the future. There's no present value in this first part of the computation. The 3,200 is our PMT because we're getting that exact same amount every year for 4 years. And then we are computing the future value. So what we're saying is, okay, as we get this $3,200 in each year, we're going to reinvest it in projects at least earning 10%. So what is that really going to earn us? So 4 is the N, 10 is the IY, 0 out the present value, 3,200 is our payment, and then compute the future value. So that gives me $14,851.20. Then I come down and say, okay, well now let's calculate the actual return on this project. So in that case, we're going to factor in the present value. So it's a 4-year project. We're trying to figure out the return now. So we're going to compute the IY. The $6,000 that we have to outlay today is our present value. Again, it's an outflow, so we'll make it negative. We are not going to have any payment. We are going to put in the $14,851.20 as our future value and then compute our IY. So 4 is still our N. We're computing the IY, so skip over that. 6,000, hit the plus or minus button to make it negative and push your PV button. Zero out the payment. 14,851.20 is our future value, and then compute the IY. So that gives us 25.43 as our modified internal rate of return. Okay, then we've got, sorry, I've gone too far. We've got this project here, this next one where it's 2 mutually exclusive projects. The CFO wants to use the net present value and the CEO wants to use the internal rate of return. If they go with the CEO's preference, which is the internal rate of return, what is our difference in net present values? Okay, so we're going to copy these over. We're going to clear this canvas and start over. All right, so something's amiss on that. This is all a year off. I wonder if I can. Okay. So again, we're going to calculate the net present value and the internal rate of return, and then compare the net present values. So again, go into our cash flow function. We've got our cash flow. So project 1, cash flow for year 0 is 1,800 negative, and enter. The first cash flow is 1,100, enter, and that is a frequency of 1. The second cash flow is 1,200, hit enter, and that is a frequency of 1. Then our third cash flow is 100, hit enter, and that is a frequency of 2. And then we'll come over to the net present value, put our I equal to the cost of capital, which I didn't copy out, right? Doesn't give me a cost of capital in here. So let's go ahead and say if our weighted average cost of capital So our weighted average cost of capital is 10%. We'll compute that net present value. We've got 1,800, hit the negative button and hit enter for our cash flow for year 0. 1,100, hit enter for 1. Arrow past that frequency field. 1,200 for cash flow for 2. 100 cash flow for for cash flow for year 3, and then make that frequency a 2 and hit enter. And then if you're going over top of it, just make sure you don't have anything in year 4. Come over to net present value. Our I is equal to 10. Push compute, and that gives us $335.17 if I round it. Okay, then we'll go ahead and do the project 2. Oh wait, sorry. We got to do the internal rate of return. Then come over to the internal rate of return, push compute. And that gives me 22.35. Okay, then now we'll come over and do the next project. So then that we hit the cash flow function. Again, we're focused on project 2. Our cash flow for year 0 for project 2 is 2,500. Hit the plus or minus button to make it negative and then hit enter. Cash flow for year 1 is 750. Hit enter. That frequency is 1. Cash flow for year 2 is 850. Hit enter. And that frequency is 1. Cash flow for year 3 is 950. Hit enter. And that frequency is 1. And then finally, our cash flow for year 4 is 1,500. Hit enter. And that frequency is also 1. Then we'll come to the net present value. Our I is going to be equal to 10. And then we're going to compute the net present value. Go to our cash flow function, 2,500, make it negative, push enter, is our cash flow for year 0. 750 is our cash flow for year 1, push enter, frequency of 1. 850 is cash flow for year 2, hit enter, frequency of 1. 950 is cash flow for year 3, hit enter, frequency of 1, hit enter. Then our cash flow for year 4 is 1,500, hit enter, frequency of 1. Come over to the net present value button, our I is equal to 10, arrow down and compute, and that gives us 622.57 if I round it. And then we'll come over to the internal rate of return and push compute. That gives us 19.78. So then what this is saying is, okay, because if the CFO wants to go by the best internal rate of return, it's going to be project 1. And it's primarily because project 1 pays back so quickly. If you look here, you get your largest 2 cash flows are in those first 2 years. You're gonna have a payback period of 1 point some years. So that's what makes that internal rate of return higher. This one, it's going to take more like 3 years or closer to 3 years to pay back. So it makes that internal rate of return lower. So if we go with the internal rate of return, which I'll be honest and say that is normally the one I like, it's never the one the textbook likes, but it's always the one that I like, that we would have a difference in net present value of 622.57 minus the 335.17. So that's a $287.40 difference. And again, if the CFO won, that's basically what they would be losing. But then again, I feel like just the timing involved would make it a better decision anyhow. But that's just me. Okay, then we move on to our last chapter, chapter 12. And I'm going to go ahead and do a separate video for those because, again, the video is going to be kind of longer.